Physics Part 87. Frictional forces are also important in considering the motion of a body through a liquid or gas. We use the term viscous force to describe the frictional force in a fluid, such as air resistance. The property of the fluid determining the force is called viscosity of the fluid. In the previous section we consider the fact that parachutists eventually fall with a constant terminal velocity because of air resistance. Newton's laws of motion. Isaac Newton, 1642-1727, used Galileo's ideas to produce a theory of motion, expressed in his 3 laws of motion. The first law of motion restates Galileo's deduction about the natural state of a body. Every body continues in its state of rest or of uniform motion in a straight line, unless compelled to change that state by a net force. This law tells us everybody continues in its state of rest or of uniform motion in a straight line, unless compelled to change that state by a net force. This is first law of motion by Isaac Newton, and it is restated on Galileo's deduction about the natural state of a body. This law tells us what a force does. It disturbs the state of rest or uniform motion of a body. The property of a body to stay in a state of rest or uniform motion is called inertia. Newton's second law tells us what happens if a force is exerted on a body. It causes the velocity to change. A force exerted on a body and rest makes it move. It gives it a velocity. It causes the velocity to change. A force exerted on a body at rest makes it move. It gives it a velocity. A force exerted on a moving body may make its speed increase or decrease, or change its direction of motion. A change in speed or velocity is an acceleration. Newton's second law defines the magnitude of this acceleration. It also introduces the idea of the mass of a body. Mass is a measure of the inertia of a body. The bigger the mass, the more difficult it is to change its state of rest or uniform motion. A simplified form of Newton's second law is: for a body of constant mass, its acceleration is directly proportional to the net force applied to it. The direction of the acceleration is in the direction of the net force. In a world equation, the law is force is equal to mass into acceleration, and in symbol F is equal to ma, where F is the force, m is the mass, and a is the acceleration. Here we have made the constant proportionality equal to unity. That is, we use an equal sign rather than proportionality sign by choosing quantities with units, which will give us simple relation. In SI units, the force F in the newtons, the mass m in kilogram, and acceleration a in meters per second per second. Acceleration a in meter per second per second.